Welcome back, people. I don't know why I did that, but I did that. Anyways, it's been exactly 3 months since I last streamed. Last stream was on 11th of January. Today is 12th of April, so 3 months. And I basically, in the meantime, I worked on a pretty cool project where I was able to build a pretty good prototype of how you can of a system where you can ask it questions in natural language and it would respond back with a graph. And because it was voice enabled, so there was voice to text. Of course, there's nothing like pure voice, but there was voice to text, and then the text would basically be passed into a particular API format in a query, and it would be sent to a particular database, and that database would respond back with some data. It would basically give you a new URL that you can hit, and it would give you the data. And then at the end, what it did was that it hit that URL, got that data, and created a graph out of it. So what I mean by that is that you can ask it questions in natural language. I won't go into details of that, but you can ask it pretty simple questions, and it would respond back with a graph. Literally, just ask it sitting. You press one button which says that okay, microphone is on, and boom, off it goes. Yeah, so that was a pretty interesting project I worked on. Other than that, I've decided to go back to a very, very old project, which is FreeSynth Python. I tried doing that back in like 2018, and 2018 2019 New Year. And it's basically an OpenAI gem wrapper for FreeSynth, which is a bootlegged version of Civilizations 2. It's a pretty damn old game. I mean, like, I'm not kidding. It's a very, 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 very old game. You can actually find this thing here called In the Beginning. Yeah, I mean, the interesting thing is they don't give the dates, but when they talk about a client server architecture on XML11 client, I mean, he's talking about back in the day, man, like playing Xpilot, Doom 1, SGI. I mean, these are pretty damn old games. Yeah. So, what's up? What are we doing today? So, what we are going to do today is two things. First is that, so there is this thing called Tab9. Unfortunately, this is not a sponsored video. They don't pay me shit because I don't have any viewers. But there's this Tab9, and I've used it twice, and by twice I mean by like two different referrals. And what I found is that it's pretty interesting thing that this thing, it's very, very interesting in a way that it has actually sped up the speed at which I type shit. Yeah, so you have this thing. You get the idea. Nobody usually sits this long for typing, but whatever. It works. It's super interesting. It's combined in all these different IDEs. Goddamn Vim. But I mean, most people, of course, are going to use VS Code or Sublime. Not, I don't know. And what else? Complete privacy, coding velocity, stay in flow, code discovery, and ace your code review. Get Tab9, it's free. A lot of people have given good testimonials, and this is pretty good. It works. It's very, very good. It's very decent. It actually works. There's one major drawback with this particular project, however, which is that when you are using this thing for a very long time, I've seen that for some reason, because they don't make this code public, you can actually just go here and you can see the engine file path. I mean, it's a binary file path. You can see how to get size of file. ls-l. Okay, cool. ls-l. Yeah, you get the idea. It's basically a binary blob. You can't read this shit. And for some reason, I've seen that when I continuously use this for like a couple of weeks or so, there's definitely something that's happening, because the processing is just too long. It takes too long to process things. And the second issue is that in places where you have poor internet connectivity, you can't actually just go out and use the Tab 9 cloud, which is pretty cool that they have that, but it's not as fast as typing things. That's part number one. And part number two is, let me find the paper, which is fine tuning. Yeah, this one. This is a pretty interesting paper. I started on whimsical shit, and it's a pretty decent app. Like, moment I started using it, I've been using it continuously for some time. Yeah, on the FreeSwift Python thing, I'm doing it under KS2 Labs name and not under anything else. So let's see. Oh, there's one issue. Yeah, I'll get back to that later. So I work with a startup based out of Chennai called Nimblebox, and what we have really realized and we are focusing a lot on is how do you improve the um, usage of neural networks. So the one way to really democratize use of neural networks across industries, and particularly for industries where a lot of people depend on a computer, on an individual computer. So for example, um, you have the paperwork heavy industries. You get data, there's a whole bunch of industries. So one thing is, how do you actually optimize this thing to run on CPUs? So there's this one particular paper called fine tuning pre-trained transformers into RNNs. Oh, yeah, okay, I've already opened it. And what they do is that they basically say that there are two major problems with transformers. One is the memory overhead, and what I mean by that is because of the quadratic complexity, memory complexity of attention mechanism, what happens is for each one, even if you add one extra token, there's a quadratic increase in the amount of memory that is required, and that's a very big limitation for CPUs. And second is because that's one particular limitation, and second thing is that for every for outputting every single token, a lot of the values from past are always reprocessed again and again and again. And so how do you get away with that particular thing? Now this paper does that. It uses basically poses the entire thing as a different setup, and then a transformer. It converts it into recurrent neural networks. And so what it achieves first of all is it has a very constant flat attention size, and number two, you can see on TPU v2 it's like outputting what goddamn like 7,000 tokens per second at sequence length of 180, which is insane. Even if you have a very long sequence length of 2048, you get the idea. Like tokens, it's number of tokens being output is 6,000. So even if you are on a CPU, you're pretty sure you're going to get like 100 tokens or so per second. If not 100, at least 60. And why 60? Because it's basically given a 10 times decrease on a performance of CPU and GPU, and a quadratic decrease, you get like 6,000 by 100 as 60. Yeah, I mean, even if you get 60 tokens per second, it's pretty fucking insane. I mean, on a CPU or a GPT, returning these things is pretty insane. Yeah, so this is something, and what we're going to do is we're going to try and implement this particular paper on live stream. Yeah, boys. What else? Yeah, and coming back to Tab 9, I mean, what is Tab 9 exactly? So one way to beat Tab 9 is to basically optimize the model. So first thing is they use a GPT-2. It's a 380 million parameter model, pretty standard private code model. I mean, yeah, all that. supported languages. Now this is a very use case specific and only I'm going to use this thing. So what I'm looking for is actually just taking in a not all these languages, because I don't use most of these languages. I only use JavaScript, Python, and recently I've started to use C and C++. And so given these two things, the main question is that if I only train a model which is much smaller, or which is smaller than this thing, but is trained fine-tuned for only these languages, these 4 languages, yeah, which is fine-tuned for these 4 languages, and optimized using something like this, I mean, you can get a much better tab 9 out of this thing, working on a CPU. Okay, so how should we begin? How should we begin? Okay, so there's this Jupyter thing open. Let's close this thing. Yes, in fun you have 4chan, Ikai, Gann textures, image dataset, Dolly baby, FC thing, Haskell, mask attention, mu0lm. What the fuck is mu0lm? What's this project about? Bogus. 511 SL. What is SL? Okay, I have no idea what it says. RM-RF SL. Cool. Tiny grad, symbolic deep learning. Okay, so let's go back. Let's do this thing. MKDS streams, CD streams, MKD. No, let's start with building a package. Yeah, on that note, I actually tried looking at the code search net, which is an open source dataset by GitHub. It's like what, 20 GB or so. It's not that big, and thanks to the fiber I'm using, man, I love optic fiber. It's so fast. It's like yeah, I mean, let's see. So we'll first start with our own thing, which is the first thing we are going to build is, I'm going to call it git dumper. Is there something called git dumper? Oh, there is git tools. Git dumper, a tool to dump GitHub repositories. A tool will first check the directory listing is exactly available. If it will just recursively download .git folders, what you would do with wget, fetch all common files, run a git checkout to recover a currently working tree. Now we don't need any of that, because all we need is we just need to download a whole bunch of okay, so what are we going to do? The first thing we're going to do is we're going to basically dump 20 GB of Python code, 10 GB of Python code, I don't know. Let's see how many we can get on my local machine. And then what we are going to do is we are going to parse that entire thing. Yeah. Okay. So create, goddammit, should we create a new notebook or in this thing? No, that's not. It's basically just file, so fuck it. Let's start with Jupyter Notebook instance. Yeah, so this is the GitHub API for using this thing. We are probably not going to use that because we have iGEM, which is again a very interesting thing. Cool. We have all this shit. Yeah, we are probably not going to use git dumper or yeah, we're just we're not going to use GitHub APIs. or we will, I don't know. Let's see. So one interesting thing is that you can actually just oh, you have advanced search. Oh, interesting. Is if we can just build a Selenium object, scrape using Selenium, I think that would be pretty interesting. Code, issues, user options, wiki options. No, I would just want search. I don't have anything specific. Python language, Python. Yeah. Oh my god, goddamn Chinese. G-test. It's pretty interesting that the Chinese guy actually comment in their own language. Yeah, so we are first going to build basically a single notebook. Let's just say that allows you to download things for a specific language, and then we are going to convert that notebook to a Python script and run that Python script across a bunch of all the cores to download all this shit faster. And in the meantime, then we are going to start focusing on this particular paper and how we can implement this thing, because the part after this thing is not that big of a deal. I mean, you can just training this model is it's not that big of a deal. You can use, if you are interested, you can use Collab, but I highly recommend that you use Nimblebox. Of course, I'm part of Nimblebox, that's why I'm suggesting Nimblebox, but you should use Nimblebox. They're pretty cheap, they give you good credits, and it has a nice dashboard. And what's interesting is you can actually add GIFs on top of this thing. And you're going to have mini archive here, so you can see papers and all that shit. People still haven't added it. They will add it, I trust them. Yeah. Okay, let's see. Okay, so what do we have? The first thing we need, let's search code. While amazing language code is, we're going to hit this thing. Yeah, the way you can actually build this thing, it's not that difficult, is you need to format your shit like this. Search code q is equal to language Python and organization is transformers. Now what this does is that it returns the entire Python code for the repository of organization. Transformers or Hugging Face. Let's see what it returns. Yeah, so it's going to return the entire search result for all the packages or all the links. Total item count is this. Yeah, I mean, what you can possibly do is you can basically hit this thing for the top 100 largest organizations on GitHubs, fetch all the Python files that these guys are using, and simply, yeah, you'll need to get this particular Python file. You'll need to modify it so you get, yeah, you have this blob, right? Let's see, this is the correct blob, I believe. TF datasets. Cool. Does that actually work with Google? Let's see. Damn, boy. Damn. Tayum. Flags. You have reports to BQ. What is this? You have main pie. You have repositories. Yeah, one way to do it is you'll first hit the organizations and get all the repositories that these guys have. Yeah, so you can just go to repositories, possibly make a pretty simple query, which is like this. This thing, and orgs is Google. Yeah, so it's going to return you a whole bunch of data points. You get data. There's you have all these repositories, which is Google Truth, second is Google Ruby, Open Apps Discovery. What is the data points that we get out of this? Do I have languages? I have the size, I have language, and okay, so we can possibly filter it by saying that you don't need to do any of that. You can possibly just get away with requests. You can take any repository that you have, and even if it's not the primary language of this repository is not Python, you can just you can still find code using the GitHub API for this thing. And we are going to be like nice on the GitHub API. We are going to give it a timeout of 3 seconds or 2 seconds per request, so we don't bombard it with shit. Yeah, let's start with this thing. By the way, you can also use OpenVINO optimization on top of this thing, and damn, OpenVINO is really fast if you can get it to work right, which is a little bit tricky, but you can. I mean, we tried. We basically at Nimblebox have like a pretty good command line interface where you can simply take any package or any Hugging Face model that you have, and you convert that to an OpenVINO optimized model, and you can get like, on my local machine, you can get like 2x boost. On a server that is AWS 12x large, you can get like a 50x boost in like generation. It's pretty fast. Okay, get first I need to check what are the version on my system, because yesterday I had to redo the whole system. It's pretty fucked up. And finally, what is the pre-version? 3.8. This thing matches. Cool. Now import requests. Yeah, requests dot get. That's it. That's how you do it, right? Yeah, and then you give it the URL and quarks. Optional argument that the request takes. What the fuck are those optional arguments, man? If I just give it this thing, what does it do? Content dot decode UTF-8, I would say. Cool. And then you can just do import JSON, and you can simply do data is equal to JSON dot loads data 0. Okay, so this is one particular repository, which is the Google Truth. And now, what is the metadata that you would like to store for each one of these? Now, I don't have any intention of breaking any licensing agreement or whatever. I just need the code, and I'm to train a particular model. I think I can get away with that. So but because I'm also going to be releasing this particular data set, I want the license to be correct. Okay, so what are the keys to keep? Which is, first you have the license, which is obviously you need the license. What else do you need? You need the size, and then you need the home page, then you need the git URL. You don't need the SSH or clone URL or whatever it is. Neither do you need any of these things. You'll of course need the created at, updated at, and pushed at, because this is useful for dating this particular data set. Oh my god. Owner, of course. I want to keep the ownership as is. I don't know, fuck with these guys. Full name and name and ID. Full name, fuck it. Name and ID. Cool. These are the keys that we want to keep. Yeah. And yeah, I mean repos, and what you're going to do is repos is equal to r k comma rk for k in keys to keep for r in repos. Cool. You have this thing, you have the license, size, homepage, kit URL, owner, name and ID. Yeah, and what we can do is we can actually reformat this thing. Now I understand this is not a very interesting task, but we still need to do all of these things. I think I would need to send in some parameters that you get from organizations, which is per page is equal to 100. Let's see what happens. $30. Okay. Perhaps is that how it works? God damn it. Apparently this is not how it works. How do I get all the organizations? Exploring GitHub APIs. Repos page is equal to 3 per page. Okay, let's just try to hit this exact URL and then see what happens. Yeah, my boy. Yeah, my boy. Yeah, my boy. Cool. And how many pages does it have? Can I do this thing? 300. 0. Okay. So I'll basically keep on incrementing, and page is page 0 valid request. Okay, page 0. So you start from 0. You keep on hitting this thing till you get basically get 0 URLs, and yeah, that's how you do. Next thing, what we are going to do is we are going to do repos is equal to, I will probably need to map this thing. So first thing we need to do is we need to reformat this thing so anybody can start using it. We want to make it as easy as possible. Okay. Skia, what the fuck is this? Owner is Google. Do we even need to keep this entire thing? I don't think we need to keep this thing. We can keep the HTML URL, followers URL. No, we don't need any of these things. Type is organization. Yeah, what are the exact things you need to proc one packet? Is you have the repo R2 is a dictionary, and what you do is R2 size, homepage, get URL, create that, push that, which are these things, for k in, and you have R2 k is equal to RK, and then you are left with owner, full name, ID, and these things go as well. Yeah, and finally you're going to have license. Yeah, let the license be as is. I don't want to mess this part up. So license goes as our license, and finally R2 for owner login, you have our owner login. You have the owner ID, OWNER ID, which gives you our owner ID, and you have the HTML URL, which you would have right now. This is the home page, so you have the get URL, and what you are going to do is R2 HTML URL is basically this thing. Cool. What else? Yeah, you don't need any of this. You need owner ID. Yeah, owner ID is added. Size. Cool. You can just do return R2. If I don't do this and I only do repos is equal to list map proc1 packet to repos. Boom. There you are. Full name is this thing, and from full name, yeah, I mean full name is good enough. Okay, so that's one part is done. Process one thing, one repo packet from the APIs of GitHub. Next, what we do is, GitHub is small, right? We can just delete this particular line. We don't need that. Yeah. Next, we hit the URL of that particular repository and find all these things. So you have God damn it. Yeah, Google / let's try with this thing, which is Google Skia, and this then becomes plus rep. Oh fuck it. REPO. Boom. Yeah, so you have these files. You do get these files, and you can just do per page is equal to 100. Okay, so let's just copy this thing for now. Search URL is this, and you basically have the full name. Yeah, you have the full name that goes here. Full name, and the rest of it basically stays the same. So what I can do is I can just use search URL dot format repos import random random dot choice repos. Cool. And rec, and I can just do this thing. I'll do this thing all over again. And files is equal to this thing. What is file 0? Oh fuck. Not found. Google vector math dart. The fuck? Let's try with this particular URL. Let's see if this thing works. Interesting. Oh, so is it possible that this thing has no Python file? Languages, yeah, I mean this thing has no Python file. Not found. Interesting. God damn it. Cool. So when there is no object, in that case it is going to return this thing. At one point I actually tried cloning all these repositories one by one, but it's not justice, it's just not worth it. What else? Autopass, yeah, this thing would have something. Message not found. Google / autopass. Oh, everything is in Ruby. Oh fuck! Does languages return more than one thing? Like if yeah, all these things, and then you have language, which is Dart, but this thing is just the most used language. It actually does not talk about all the languages that they are present in this thing. So let's open this thing. For example, you have tracer, compiler. Damn boy. Is this some kind of a leak that this thing is inside the organization? It's not. No, it's not. Google just doesn't fuck up like that. So you have two languages, but it basically returns just one language, just JavaScript. So yeah, what you're going to do is you're going to simply say if not found, then come on, man. Has to be something for TensorFlow. For PyTorch, and possibly just remove this thing. Yeah, better. Okay. So this thing goes into the dump. You don't need any of that. Just do this thing. Yeah, and you have total count as this thing. It is good because you get all the possible files in a single hit, which is you know all the files that are available in a particular project. Google Graphica. Total count is 0. Cool, this is how it works. Okay, so next basically what we do is we iterate for each of these repositories, find code, but then how do I find for all of them? fucking hate software development, man. And page maybe. Let's try PyTorch and page is equal to 100. Only first 1000 search results are available. Why is that? Do I need to give in like the token and all? But I want to get all these things now. For this particular item, I don't need any of it except the git HTML URL. Yeah, I don't need any of that. Get all the files in a repo, GitHub, API search, that's fine. I mean, even if it returns first 1000 files, because you're eventually going to hit so many files, you can get away with it. Okay. Now how do I get all the organizations? I need like thousands of organizations for this thing. GitHub all Python files. I get something like this. Oh, Python. MyPy, optional static typing for Python 3 and 2. By the way, how do you do it for C++? Language is C++. Oh, it actually works. You just do .h, which is CPP. Cool. Okay, so let's start writing the script for this thing. Import requests. The fuck? I was just talking how good you are. Tab 9, don't fuck with me right now. Python import JSON, import from tqdm, import trange, and what else do you need? No, you don't need random. Okay, so the first thing you'll need, this is basically the structure org page, and let per page be 100. That's completely fine because that's a maximum number. So org repos URL is this thing, and next you have the search URL file, which is this thing, and instead of language you're going to have language, oh shit, sorry, that's not correct, language, and other constants is C language CPP is CPP, language C is just C, language Python is Python, and language JS is JS. Now is it JavaScript? I think it should JavaScript. No. Where's the file? .frag, motherfuckers. GitHub, search, languages. If I just do JS, what happens? Yeah, just doing JS works, and if I just do language C, should we even include C? Because C++ pretty much handles the entirety of it. C++ has everything. You don't really need to write. C++ is basically just C, advanced version of C. I want to clarify that part. And so how are you going to do it? You are either going to use multiprocessing or you're going to use multi-threading. In this case, I would prefer to use multiprocessing. Import multiprocessing, sorry, as MP, and def search, no, get args basically. This is orgs repo URL. You also need the orgs URL, which is how you search the organizations, list organizations. So you do this question mark per page, per page is equal to, let's do 2. Yeah, so this is how it works. And you can possibly add a since, because you do not need all the organizations. That would be very stupid. So you can possibly have since and since this is 10,000. So Google's ID was, fuck, what was Google's ID? Oh fuck me. B repos 0, fuck 0. Organization ID, this thing. Yeah. Google low everyone shares, motherfucking ace, motherfucker. Let's do this thing. Alright, so the first thing you need to do is you need to fetch all the organizations. So the way all organization works is like this. Fuck you. Question marks per page since 1000. But every time you hit this thing, you would need to keep a counter of the latest ID. That is how you can actually get away with this thing. Yeah. So get orgs. first thing you would do is mamma mia, you have since in it is like 100,000, 1 million, 100,000. The way GetOx is going to work is that you're going to do all these things, which is data, this thing, and you don't actually hit this particular URL. What you do is, for while true, basically we want to get all the possible organization dump orgs URL dot format since is equal to since is equal to since init. You just do dot decode data is equal to this thing. You get the idea. Basically returns nothing if len data is equal to 0 break. All args is equal to this thing, and we need to keep the login ID. Yeah, we just need to keep the login and ID. That's it. And what we do instead is all args dot append, extend not data login k is to dk for k in login and ID for dn data, return all args, and we're also going to use pickle import. Should we use pickle? No, JSON dumps is just fine. And we should not use JSON dumps. We need to include time.sleep from time import sleep. Between each hit query, we would like to sleep for sleep timeout is equal to 1 second. That's not a lot, but you know what, let's just see. We would also like to keep some kind of logging and printing. CNTR basically CNTR is 0 number of times the API has been hit, so this thing just becomes equals to 1, and if CNTR every per page is going to be 100, so every time we pull 1000 every time we pull 50 organizations, we would like to print this. So 50 is equal to 0, print number of API requests CNTR and number of or then how it works. Okay, I save this thing. I need to save this thing in AI notebooks. Get.py. If I simply do this, let's see how it works. Python 3 get.py. Oh fuck, not imd.py. Oh, I'm in streams. Oh shit. Yeah, I go to notebooks. I basically pull it back. And I go to streams. Cool. Git and git. Okay. So Python 3 get.py. The fuck? Oh. Okay. So once I get all args is equal to get args with open dot slash args dump dot json as w as ff dot write json dot dumps all args. Cool. And print starting getting args. Oh fuck this shit. AI streams get. Let's see what happens. If I go to my activity monitor, can I see which thing is hitting all these things? NSD tab 9 local, tab 9. Tab 9 is sending usage statistics, which I don't like, but meh. Okay, string indices must be integers. The fuck? While to try. Yeah. Except I don't need any of that. Exception as print and print data. Yeah, let's see if this thing works. I need to authenticated requests. GitHub API authentication. How do I pass headers? Pass header requests Python. Oh, we just do headers this time. Cool. So I am going to take my auth protocol. So I'm going to move it to another screen because I don't want the fucker stealing my tokens. GitHub auth token, access token. Delete these tokens, generate a new token. This thing, confirm password, note, get. This thing has write, delete, admin, notification. I don't need any of these things. It's just for one particular use case. Okay, and next I need to set my environment variable. Export, can't see it right now. Export git token echo dollar get token. Cool. So import OS, and I can just do get token is equal to OS dot environ get token. Okay, this is right version. So what is the header? Authorization token. Authorization token and token. Okay. So this thing goes as this. F this thing token get token. Let's see if this thing works now. I also need to check the rate limiting. Like, how do you actually hit this thing? For API requests using basic auth, you can make 5,000 requests per hour. This means that all OAuth applications authorized by the user share the same quota of 5,000 requests per hour when they authenticate with different tokens owned by the same user. Okay. So with search you can make up to 30 requests per minute. Well, let's see. I mean, if I just want to get the data, I can just hit pay pricing for this thing. Decline. Let me just message. Oh, motherfucker. So it has made 100 API requests. I'm limited by what, 5,000? Oh shit, I need to do check. I need to run this thing. My authorization. So, oh fuck, I need to do this thing all over again. Oh, god damn it. Echo $get token. Echo $get token. Oh fuck me. Oh no, I got it. Cool. Authorization token, this thing. So what is the spelling of authorization? This is the spelling of authorization, and I can just do this. Let's see what is my limit. I have used 175. I have used 186 now. Should probably also print fuck. I have not updated this shit. What a fucking nightmare. Okay. Since is equal to data minus 1. What do I have? Since ID, so anything that is greater than this thing finally goes through here, and this thing basically breaks it, and we say print data, print max since is equal to since. Cool. Does it work now? I've not used TQDM or T-range. I should probably just use T-range. It's a tiring, pain in the ass process collecting the data points. So I'll work on this. In the meantime, let's just get back to this thing, and we'll create a new notebook, which is, let's update this thing we already done. Trans RNN. Nobody knows what's the gender of this thing, but okay, even it doesn't know what's the gender of itself. Transformers import torch. Now what we want to exactly do is we want to use a GPT-2 pre-trained model, or a GPT-2 model from transformers, and use that to fine-tune as RNNs. So from torch import, and then from torch.nn import functional as f, and from transformers import GPT2. Or is it even installed? No, it's installed. Cool. GPT2 LM and model. You take these two things, define a tiny model. Tiny conf is equal to GPT2 config, and then you have all these things, and what you can do instead is you will simply put a tiny model here, which is vocab size of 123 or 128. Number of positions is 12, and CTX is 12, embedding dimensions is 8, number of layers is 2, number of heads is 2, and tiny and model basically is GPT2 LM head model dot tiny conf model dot num parameters, and we do model dot init. Wait, cool. I have 2880 parameters here, and okay, so this is your model, this is your transformer, and at the core of everything sits the transformer model, and on top of transformer you have the LM head. So we don't need to modify any of this. All we need to do is we actually need to modify the attention layers, because the rest of it is pretty much the same. You don't need to do anything with that particular part. So let's get to the paper and see how it works. This is not a paper explanation kind of thing, but okay, so transformers have outperformed recurrent neural networks in natural language generation. This comes with a significant computational overhead as attention mechanism scales with a quadratic complexity in sequence length. Randomized heuristic feature maps, but can be difficult to train or yield suboptimal convergence. This work aims to convert a pre-trained transformer into efficient recurrent counterpart, improving the efficiency while retaining the accuracy. Specifically, we propose swap then fine-tune procedure. In an off-the-shelf pre-trained transformer, we replace the softmax attention with its linear complexity recurrent alternative and then fine-tune. With a learned feature map, our approach provides an improved trade-off between efficiency and accuracy over the standard transformer and other recurrent variants. Cool. So what they say is this thing. The way it works is that you have you basically have two vectors or two set of vectors. First is the source and second is the target. The target is the query and key and value are the source tokens, and from these things you convert the source tokens to first the key and then the source tokens to value, and each of these operations is mth square. In how they extract mth square is given here. So transformer figure 1 depicts the transformer computation steps from input vectors and the time complexity. Here we assume that a complexity of multiplying an NM matrix by an MK is O and MK, and so what you have is you have O and MK. So what you have is you have M as, which is the total number of tokens in the source, and H is basically the linear dimension of each particular head, and that's how you get MHH or MH squared. And similarly for source query you get NHH or NH square. Now they repose the entire problem. Oh, I'm so sorry, it's super late here. They repose the entire problem like this. The similarity of the way similarity of transformers works is it has the softmax similarity, multi-hit similarity, sorry. The similarity is given by the softmax output of the um, key and each key and query um, vector divided by the root of the total dimensionality of the root of total embedding dimensions. Okay. And instead what they propose is that they say this is replaced by first replace the dot then exponential similarity function in the pre-trained transformer by basically multiplying it with each other. So you have phi x, which is given as this function, which is you have the it's a pretty straightforward linear layer with ReLU activation. And now the interesting thing is that both of these use the same weights, and so you can get away with this problem where you don't you can get away with just computing this thing once, which is what the major improvement of this one of the major improvements of this algorithm is. And second, what they say is that we can reformulate the attention mechanism like this. So you have this similarity first given by the exponential, now given by this particular similarity function. You repose this entire problem like this, break it down, blah 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 blah, and eventually what you get is you get something like this, which is Si is equal to Si minus 1 plus phi ki Vi transpose, and Zi is equal to this thing, where then you can simply plug these values here. Basically you get this thing and this thing, and eventually what you can do is you can also merge, you can use the already known weights and create the new weights, which is given by this thing. So you have W phi into WQ given as the new WQ, and why this is used is because W phi is actually much smaller than the actual dimension. And so what happens is instead of performing two different operations of first multiplying it by phi q, basically getting the query vector and the key vector, and then again multiplying it to get the lower dimensionality, you can cache this value just at the start and then run this thing again. You can simply cache these values at the start and plug these back in. And so they demonstrate basically that you can get away with much smaller you can get away with much smaller attention size as well as the speed. Okay, so what we are going to do is we are going to try and do this part, convert this into this thing on our tiny model. Okay, so let's model this thing with this class T2R and module def in itself super init, and you have so basically the only thing that is new is T2R attention. Everything else basically is just the same. Def we also need to train a very simple model for this particular task. So we first it's capturing all these data points. Let's see how many requests I have left. Oh, I have 4,300 requests left. That's per hour, so I have a lot of things I can actually pull through. Okay. We'll also need a very tiny data set to actually run this thing through. So let's just pick a very small data set, which is Let's just pick any Wikipedia entry. Oh, these are a lot of data points, man. Wikipedia, newspaper, Python, newspaper 3K. Okay, so what I'll do is I'll simply I'll first install this thing, which I can do using newspaper pip 3 install newspaper 3K and URL library 3. Requirement already satisfied. Cool. And then I can just do this, which is from newspaper import article. B, I can do article.url. Article, and the URL is this thing. Article.text. There's no text because I first need to download this thing, then parse, and then text. Download, parse, text. Okay. And I can just do this, I think. Cool. Then this thing, and you can also clean it by saying that import re regex -w. What is -w metacar? You can just say sample text is re.sub. With this, anything that is not A to Z, lower, of course. We need to reduce the vocab size as much as possible. A to Z, 0 to 9. Is that correct? It is not correct actually. And spaces, of course. And another thing will sub. You know what? Fuck it. I think this is good enough. Len sample text. Total tokens is this thing. Total. And vocab size is just len set sample text 30. Cool. And actually, to see if there is an actual improvement, we are going to use number of positions as 64. This thing, we get the model, and then we are going to basically get slices of all these things. So from iter tools import is slice. No, I'm not exactly sure how to use this thing. thing clearly does not work like that. Instead, you know what we'll do is I is to I plus 100 for I in range length sample text. Yeah, I mean, alright, cool. Length strings, that's it. Patches, and the number of patches you have is you have 747 patches. Interesting. 747 motherfuckers. Okay, what else do you have? You need a vocab, which is just a is to I for I comma k in vocab is this thing UNK. Yeah, UN is fine enough. In enumerate UNK and vocab. Cool. There's a concept of sorting with this thing, but still. Oh, there is a concept of sorting. Cool. We have all these vocabularies and patches and tokens. Let's just call it patches only. Is vocab X for X in X. Let's call it Y for X in batches. And your batches basically shit, don't oh fuck it. And you can actually import numpy and convert this to a fixed tensor. Import numpy as np. You can convert this to an array, so you can fetch the shit much faster. np dot array. I can do up to -1. No. Oh, so apparently there's some problem, which is len x for x in this thing. Oh, cool. So this is your tiny data set, and what we need is a tiny trainer. Yeah, I mean, you can just do torch dot from numpy this thing and just convert this to long, so it's much more easily available. And you'll need from torch dot utils dot data import data loader tensor dataset, and ts is equal to tensor dataset batches. I can just do 12 and returns for this tensor. Alright, motherfuckers, this is cool. Yeah, DL. Okay, for in range d range, I would like to actually also print this thing from tqdm import d range. I mean, why am I even writing all this code, man? This is why I need this thing built. This is so stupid. 100. You have p bar as this thing in p bar. Oh You know what? I'm going to take a 10-minute break. Let's listen to some good music. Hmm. Lifeline. White ribbon day. Okay, I'm going to mute you guys and listen to this shit. Okay, so there's actually no way to filter things in organization, and what I mean by that is if I only want organization that have over 10 repositories, there's no way to get that. List users, you can of course also list users per page, but with organizations you are much more guaranteed to get better code than with users. Also the number of users is like insanely large. Oh yeah. So you can train this. Oh damn boy. Okay, so you have this entire model trained, and you get the idea. It actually works. So if I give it ts0 0 up to like 10 tokens, and a model dot generate input IDs is this thing, do sample is equal to true, num return sequences is equal to 10, outputs is this thing. Yeah, and you can do outputs. What the fuck? What the fuck, man? Max. We need to do max length equal to 10. Is equal to 9. No, not even 9. Let's just do 43 max length. Top K 10, top P 0.9 outputs. What the fuck? Why is it not working? Model.eval .toList. Okay, this is a bad idea. 31 19 dot. Alright, we need to unsqueeze this thing. Unsqueeze. Much better. And then I can do outputs dot to list sec for sec in this, and okay, I need an inverse vocab. I need vocab is equal to I is to k for I comma k in enumerate u and q, and I have inverse vocab x for x in sec. Fuck you. Dot join well, still better than before. I mean, at least if the loss goes down, we know that it's training. Okay. Next, all we need to do is we need to do model torch dot save model dot state dict. Where should we save this thing? We will save this as tinywiki.pt. Okay, and now we'll do torch dot load a tinywiki.pt model is equal to this thing, and this basically returns an ordered dictionary that does all this thing. it basically returns a dictionary with all these weights. Now you can of course do gpt2 dot from retrain, tiny on the load state detect. Then you do a model and oh fuck, model is this thing. Model dot load state detect. You get this model. Yeah, this is how you can get this thing. But yeah, you can just do model dot state detect, and it gives you this particular dictionary. Now the idea is that how do you actually convert this entire thing to an attention thing. Now for simplicity you can of course do that, but we're not going to do that. I'm going to take the state dict. You know what, I'm gonna do all this thing later because I am really sleepy right now, and man, I can complete both of these things. I will. Okay, toodles, see you tomorrow.